Thank you, Vladimir. Good morning, everyone. I hope you're doing fine. And I sincerely hope the next time we will speak in a person. But it's just that now we have these uncertain circumstances, so let's do it live this time. I would like to welcome you in front of Microsoft Development Center Serbia. We're very glad that we support this event and to have this amazing community. And before we get started, I would like to express my sincere appreciation to all of you who generously helped this become a success and even be possible in the first place. For everyone who joined us to watch, in case you didn't check agenda, please do so. There is a lot of great content, so please stick with us today. So let me start with something that we all know. We are witnessing explosion of data for some years already. That's nothing new, right? So data is growing every day in volume, velocity, variety, and it is really coming out of everything. We have these smart devices around us, Internet of Things, sensors, all kinds of producers producing data at a high rate and in a different formats. So until now, it's no longer a challenge to produce and store this data. You can store infinite amounts of data in Azure storage, or you can ingest data at a high rate to Cosmos DB. But when it comes to a consumption phase, there are some challenges. Organizations try to use this data to make their decisions better. They use this data in structured and semi-structured formats. They do the analysis in a real mode and in a batch modes. But the tools that we currently, on solutions that we currently use, that we used until now, can no longer address these kind of dimensions. And it was a long time since businesses discovered that there is a direct link between business performance and decisions based on a data. So businesses are striving to provide data to each and every person in the organization to provide it in a meaningful and a useful and actionable way. And this is driving a digital disruption that's forcing every company and every industry to reimagine themselves, to rethink how their business processes work, to rethink how they engage with the customers, and to rethink how they leverage their data. We see these examples all around us of this reinvention. You probably noticed that the retail industry has changed the way they interact with us. Now we are having the completely new integrated customer experience. So you can start a conversation or interaction with a brand on a website, and then when you show up in a store, you just continue the conversation where it stopped on the web. So all the channels are now well integrated. Another example where we see this change is financial services. So financial services is seeing the end of bankers' hours. Consumers demand access to their funds 24/7 from any location, from any device, and not just access to funds like I want to pay some bill or something like that. It goes even further. Consumers no longer want to go to the office. They want to start using products and the new services out of comforts of their homes. The framework we use to highlight digital transformation, how digital transformation is enabled, is what we call digital feedback loop. And at the center of this digital feedback loop is, of course, data. So once data is transformed into meaningful insights and action, it can do wonders for both organizations and customers and everyone involved. By analyzing customer signals, meaning customer behavior, customer interaction with environment, you can better engage with the customers and therefore deeper relationships with your customers. By analyzing your operational data, you can become more efficient, have more efficient operations, find ways to reduce costs, or find a way to improve the performance of your processes. So basically, you can re-engineer your processes. By analyzing your product telemetry, you can learn how users interact with your product. Maybe there is a place where a lot of users just abandon using the product, or maybe there is a hot pot when they use your product. You can use this information, feed it into your product group, and therefore make a better products. And by combining all this information, all this data actually, and providing it to your employees, you empower your employees to become more efficient. Ultimately, everyone benefits from this. And businesses need a high-performance database and a high-performance analytics system to reason over this data, to garner insights and take intelligent actions. And then what businesses can do? They need to decide on approach. So even before you start working on a business analytics solution, you need to decide on approach that you want to take. And even before you start deciding on a technology that you will use, you need to make a decision of this approach. So you can use either data lake or a data warehouse approach. And of course, both of these approaches have their own pros and cons. So let me start with the data lake and briefly explain what it is. So data lake is an approach where you keep all your data in a raw format in a data lake, Azure storage, let's say. And it's mostly semi-structured, and you use some big data platform. Perhaps you can use Spark also, and you can do some experimentation on top of those data, do some fast exploration, and this platform is very good actually for these kind of things. But it comes with a caveat. It mostly lacks the enterprise level security, governance, and privacy standards. On the other hand, there is a data warehouse, which means that you ingest your data into highly structured relational format, and then you benefit from having a very good performance over your analytical workload, and you have well-proven enterprise level security, privacy, and the governance. But this also comes with a caveat. You need to make a transformation of your data from the source systems into the data warehouse, and these kind of transformations are often quite complex. There are so many of them, and it is in the end tedious work. So some organizations decide to go with both approaches in order to have the best of both worlds. But when you decide to go with the two platforms, two separate independent solutions for analytics, then you have some additional challenges. You have incoherent security models, meaning that when you set up a user in one platform, you also need to set up a user in the other platform. So you need experts knowing both and keep them in sync. As those are different platforms, obviously they have different development tools, and it has somewhat diverged deployment strategies. Important point, especially in the recent years, is whether you will use serverless or provisioned services. Provisioned means that you will decide upfront how many resources you need, and you will pay for the uptime of these resources. It's great for constant workload, 24/7 and such things. But if you have some bursts of workloads or maybe ad hoc analysis, then you will probably like to have serverless offering, meaning that you just connect and don't worry about resources. It will auto-scale, it will just work out of the box. And these platforms have just one or the other, not both. When you have two platforms, you have a silo, so data and metadata. Of course, you need, let's say that you need to have a custom list of customers in both platforms. That means that you have the same list in two places. You need to keep them in sync, and you need to keep them up to date. And even if there is a difference between them, you need to know which one is correct, which is difficult to say. And when you move your analytics solution to production, you need to monitor it. So again, two different tools, and most likely two different sets of metric to monitor these tools. All these challenges, sure, businesses are somehow dealing more or less with them, but the effort they put in it and overall effort that they kind of waste into it actually exposes them at risk of inability to meet business SLAs. So systems are complex, processes are slow, and the correctness of data is in question. But there is a way to have both, to have the best of both worlds without worrying about challenges. So Azure Synapse Analytics is a new service in Azure which accelerates time to insight across data warehouses and big data systems. It brings together the best of both worlds. So data warehousing and big data analytics in one world. So it brings best of SQL, Apache Spark, pipelines, and web-based studio for building end-to-end analytics solutions. But I realize that this is kind of a big promise that I just made. So let me walk you through components of the Azure Synapse Analytics and go step by step. So the best thing is, the best thing is how easy it is to start with Azure Analytics, Azure Synapse Analytics. When you go to Azure portal, you create Azure Synapse Analytics workspace, and in a matter of minutes, you get your workspace. Within your workspace, you get Azure Synapse Studio, and you get Serverless SQL Pool. Azure Synapse Studio is a web UI which you use for all the interaction with the workspace. Meaning you will go to it, you will open this Azure Synapse Studio to do development, to perform the integration processes, to manage your endpoint, to configure the security, to monitor it, all kinds of things. And the Serverless SQL Pool is a service that I will spend a part of this session on. It's a serverless service that lets you query data in a data lake using a plain old T-SQL. Something that you might be familiar with the other previous products, but this time it is at least one level up, and it's also a serverless offering. So I will go into more details a bit later. But when you work in an analytics solution, you probably want to loop in teams with a different knowledge. So if there is a team working on a data warehouse, you can create for them one or more data warehouses, so you all work under the same umbrella. Further, you might have a data science team in there, and you want to loop in a Spark colleague on your project. The great thing is that all these capabilities, SQL, Spark, data warehouse, Serverless SQL, data warehouse, and Spark are under the same umbrella, and they work together. There is a common metadata layer, meaning that if you create a table in a Spark, it gets immediately visible in a Serverless SQL Pool. This way, you can finally collaborate on your work without friction. And of course, if you do some analytics, you need data. So you need some Azure Data pipeline to bring data from on-premises or cloud data into data lake. So you can build pipelines and orchestrate them. You can manage your endpoint, meaning you can add a data warehouse or dedicated SQL pool, as we call it, provisioned one, or add additional Spark, or add or remove resources to them. You can monitor your environment, like what SQL requests were there, what were Spark jobs executed, and what pipelines were executed. Finally, this is a single place. Azure Synapse Studio is a single place for you to configure access permissions for your users. So you no longer need a SQL expert and a Spark expert to configure the access for the users in a separate way, in a different services. Now this is a unified experience where you go to Azure Synapse Studio and configure the security. Once you get the insights, you probably want to connect with other services in Azure. So Azure Synapse Analytics is integrated with other services, meaning that you can easily share data with other organizations using Azure Data Share, or you can do some machine learning using Azure Machine Learning. But for sure, you would want to provide the results in the form of dashboards and reports to business users. So you will use a Power BI for that case. So you can integrate or connect Power BI with the workspace, and they will work just seamlessly. But all of this that I spoke is related to data that is kind of static. You already move the data into data warehouse, or you already have data in a data lake. In today's uncertain times, businesses need to make decisions on today's data as soon as the transaction landed in your operational system. So this is a new thing also, as well as Serverless SQL Pool. It is Azure Synapse Link, and it allows you to perform analytics over your operational data. And we built it for Cosmos DB so far. So you can perform analytics over operational data in Cosmos DB in a ways that was never meant to be done before. So let me spend some minutes speaking about the Serverless SQL Pool. Serverless SQL Pool is an interactive query service which enables you to write the plain T-SQL to query data in your Azure storage. It can read different file formats. And for those of you who already were using something similar, this is built on top of Open Set function, which has many extensions. It can access the multiple files, it can do partition elimination, it can read files without specifying schema, and so many cool things. For those who used Polybase, Serverless SQL Pool supports Polybase syntax. So without or almost without any code change, you can use the Polybase code and run it in a Serverless SQL Pool. And as this is a SQL, any tool that is capable to connect to TDS endpoint and send a SQL query will be able to connect to Serverless SQL Pool also. So you can use all the tools that you are familiar with. You can use Power BI, Azure Analysis Services, Azure Data Studio, SSMS, all the libraries, .NET, Java libraries that can work with the SQLs can work with the Serverless SQL Pool also. This means that it's quite easy for you to plug it into your existing architecture because it's just a matter of changing the connection name, the connection string, sorry. And very cool thing is that finally you can collaborate with your data science team. So let's say that someone from a data science team uses Spark and perform some magic in a Spark and store the results in a table. So far, this table was not accessible outside of Spark. But now, with this Synapse workspace, you can access that very same table using Serverless SQL Pool almost instantly, actually instantly as soon as that table is created. And then again, you can provide that table through Serverless SQL Pool to the Power BI or whichever client tool you like. As this is SQL, it means that it has proven enterprise level security. So all the concepts that you got used to, like roles, users, schemas, permissions, grant deny permissions, it's all there. And it's working the same way as it worked before. So again, you can reuse your knowledge that you have and probably the code that you already have. Also, you can organize your workloads within the databases. And now we often hear an interesting question. If this is a serverless service, what happens with those users' roles and everything that I created there, this metadata? Well, the metadata is always there. So you can stop using your endpoint and come back after a month or a year. Your metadata will be there, including all security settings, of course. And as this is serverless service, it means that there is no infrastructure to manage. There is no upfront cost and no resource reservation. So without serverless, in a provision model, you would have to decide what amount of resources are needed. Or you would need an expert that would tell you what amount of resources you need. And then you would need that very same expert to keep monitoring your workload to find out whether you need additional resources or not. But that's not the end. Actually, businesses can expect increase in a workload, or like, let's say for a new year, a lot more sales are happening than in the rest of the year. So there is a spike. So you need to plan up front for the resources that you need to have. In case of a serverless, you don't need to do that because the system service automatically scales for you. Related to charges, you pay only for query that you execute, or to be more precise, you pay for data that is processed. So if your query's target is processing 1 terabyte of data, you will be charged for 1 terabyte. If you run the very same query 5 times, you will be charged for 5 terabytes of data processed. And one important note also, when you create the Synapse Analytics workspace, you are not charged at all for anything. You are charged only when you start using Serverless SQL Pool, or when you start adding other capabilities like Spark or dedicated SQL Pool. There are two major areas where Serverless Synapse SQL Pool brings value. One is Serverless Experience, as we discussed. The other one is it greatly enhanced querying of the data lake. So for Serverless Experience, it improves the experience overall because it has auto-scaling and managed capabilities, which help you forget about the resources. So when you connect and run a query over some amount of data, with some query complexity, system or service will provide you with your endpoint with some resources. And then when you add more queries or start querying larger amounts of data or sending more complex queries, you will get more resources. But that will work just seamlessly without you even noticing that. So there is no action needed from your side to make the bigger workload work. And the system is fully pay-per-use, so there is literally no hidden costs. You can create a workspace, as we said, and there are no costs, as long as you don't run your queries. When you run queries, you are charged only for data processed. And speaking of all these users, roles, and everything I mentioned a few minutes before, for creating such things like creating databases, views, and external tables, users, roles, you don't get charged. So you're not charged for this metadata. You are charged for querying the actual data in your storage. And as you know, querying files was possible even before the Serverless SQL Pool. But it was not such a great experience. There are a few reasons. You had to know the way it worked. It utilized Polybase, which means it used the Java virtual machine. It was a separate process out of SQL, and therefore there was some slowdowns. In this case, in Serverless SQL Pool, querying is reading data is read from files directly into SQL nodes. So the only part that is not happening the same way as it was happening so far is actually reading files. So we wrote fast optimized parsers that read the files and feed them into SQL nodes. And from there on, SQL nodes utilize all the things that you already know about SQL. So 25 and more, even more years of work on a query optimization and query processing engine. So all of that is now used to process the data from the lake, and hence that's the reason why it's so fast. And finally, it's easy to use. You could write. So far, you have to write a schema of a file to know what's in the file in order to be able to query files. So you need to specify its schema, provide a path to a file, and then you can query it. With the Serverless SQL Pool, you don't need to know that much about your file. The idea is for you to be able to quickly start. So Serverless SQL Pool you can point it to a file or a set of files. It will open the file and check the content to see the schema of those files. So it can read the schema out of Parquet, and also it can read the schema from CSV files. So for you, it's just a kind of select start from file, path to file, and that's all. You will get the columns, you will get the values, data types, everything. So what are the scenarios that the Serverless SQL Pool is meant for? There are three scenarios that we see serverless as a good fit. One is data exploration. And when you get to a new project, or when you get data out of some new source system, you don't know what's in the files. And you usually need to take some tool, or other than SQL, or Notepad to open the file and then check what's in it, and then you can start querying it, only after you specify schema. With the Serverless SQL Pool, you don't need to do that. You can write queries directly without knowing nothing about files. So it's literally exploration. You don't know nothing about file, but you can query it. You can see number of columns, number of rows. You can find the maximum values, do aggregates, whatever you like. The other scenario is logical data warehouse. So for sure, most organizations have multiple operational systems. Applications that is used in sales, like some CRM, financials use some other application, and besides that, there might be some IoT events or logs, and all of that data land into the data lake. So once this data is in the data lake, you need a way to query them. So you can create a virtual SQL layer on top of this heterogeneous data in the lake. And the virtual SQL layer means that you will create external tables and views on top of your data in a data lake. So with this logical data warehouse approach, with the virtual SQL layer, your tools and applications will be able to read data, to use data from data lake, just like it was data in any other database. So basically, you abstract the data lake and provide the SQL relational access to the tools for your data lake. And finally, you probably want to do some transformations. And let's imagine that you want to pre-aggregate your data for your business users. So they will use the pre-aggregated data instead of having them to aggregate data each time all over again. So you can write the data transformation in a Serverless SQL Pool, which translates to execute this SQL statement, which does the transformation, and then materialize the result of this select statement into data lake into another set of files. This way you can do data transformation without leaving Serverless SQL Pool. So you don't need another tool to do the transformation. There are different usage patterns that we saw so far emerging from our customers. The most common one is to run BI directly over the data lake. So this is part of an architecture that you're for sure familiar with. On the left-hand side, we have these source systems and Azure Data Factory ingesting data into the data lake, per KM, CSV, JSON, whatever there is. On the right-hand side, there are business users using, let's say, Power BI, expecting some dashboard or a report, and Azure Data Studio users or analysts who are capable to write some T-SQL query. But those are two different worlds. They don't know how to work with each other. So what you can do is that you can put Serverless SQL Pool in between. You can check what's the data in a data lake, and then provide views, external tables on top of your data. And then all these users and client tools will be able to use those views to access the data in a data lake. And the good thing is that this way, your users are working with the up-to-date data. So it's always the latest data. As soon as they query the Serverless SQL Pool, Serverless SQL Pool reads the data out of the data lake. So it's always up to date. Another common usage pattern is we have organizations that are having disparate teams knowing having different skill sets and knowing different technologies. So if you have a data science team in your organization, you can work with them within Synapse Workspace. So they can use what they know best. They can use a Spark within Azure Synapse Analytics and perform some curation of data, prediction, whatever there is, and materialize the results of their work into a table. So far, no one could access that table because if you want to access it, you need to know Spark. But now with this common metadata layer that we spoke about and the Azure Synapse Analytics, this table becomes immediately available in Serverless SQL Pool. So literally, just after a few seconds after the table is created in a Spark, you can use it in a Serverless SQL Pool. And then the same way as we showed in a previous usage pattern, you can provide access to both Spark table, and any data in a data lake to Power BI and the other users. The third usage pattern is quite generic one, I would say. So as Serverless SQL Pool accepts SQL connections and provide you access to data lake, Serverless SQL Pool can be used as a connector to big data for literally any tool or solution that is capable to use SQL. And what we spoke so far, you probably noticed, I was speaking about data that is in the data lake. So already there is a lag between the data was generated in some operational system and the time that it landed into the data lake. But today, due to these uncertain times, businesses need to make decisions on today's data. And they want to reduce this lag. They want to query data directly off the operational databases. The major challenge for analytics on top of operational data is that this data in operational systems is not in a format, is not structured in a way that is suitable for analytical workloads. Hence, it's slow or even in some cases impossible to do it. And further, even if you can do it, and even you are satisfied with the performance, you will hinder performance for other users of your operational data, because you are now competing. If you're querying directly data of operational store, then you're competing for the very same resources with transactional scenarios. And this is where Azure Synapse Link comes. Azure Synapse Link enables you to query your operational data in a near real-time way. So let me quickly walk you through how that works. So organizations have one or more operational systems, or many of them. And then there is an analytics system that needs to use that data. Usually what happens is that organizations have transformations, sometimes hundreds of transformations, to bring data out of operational systems, to transform it and save it into data lake. And only then an analytics system is capable to actually process that data. And often these transformations happen once a day, sometimes even once a week or month, and less times it's hourly. But obviously there is a lag between the moment in time when data is transaction landed to the operational store and the moment when analytics system can actually make use of it. And to build all these transformations, you need big data and data warehousing knowledge. So it's not that easy. Azure Synapse Link for Azure Cosmos DB is breaking down the barrier between these OLTP and OLAP systems. It links your operational Cosmos DB database with Azure Synapse in Azure. And this is a capability that is in a preview. So it is in a preview, it is in a public preview, and you can try it out if you like it. So the idea with Azure Synapse Link for Azure Cosmos DB is to let you get and extract insights from your data as soon as it lands into Cosmos DB. So no need to manage, so you can perform a near real-time data analytics. As the data is automatically converted into analytical formats, there is no performance impact on transactional workloads because you will not be accessing directly the Cosmos DB itself. You will be connecting to analytical store. Then there is no ETL that you need to manage. So all these transformations that I mentioned on a slide before are no longer needed because they are automatically done for you. So the extraction and transformation into a format that is suitable for analytical workloads is done behind the scene. And probably the best thing here is that this is literally one click away. So what you need to do to enable Azure Synapse Link for Cosmos DB is to go to Azure Synapse Studio and to click and to enable, to connect your Synapse workspace with Azure Cosmos DB. And it's literally done just with a mouse. From there on, your data is in a matter of minutes available to you for querying your analytics system. So just a spark and ideas how you can use and for what you can use this Azure Synapse link. So on the left-hand side, we have this real-time application and services, ingesting data into Cosmos DB, actually using it as an operational or transactional store. And then there is business needs that you want to make some real-time or near real-time reporting on top of your data. Having all of this in an Azure Synapse Analytics workspace, as we saw before, you can use different technologies to analyze this data, Spark, Serverless SQL Pool. Then you can connect to Azure Machine Learning to extract some additional value out of this data that is coming in near real time. And then you can do some retail recommendation. You can detect frauds and do some health alerts or monitor your IoT hubs. And it is just a click away, and it's in near real time. So let's spend a few minutes to see how it works. As you know, Cosmos DB is a transactional store, and it has a row store optimized for transactional operations, meaning that it's built for high ingestion rates for some point lookup queries, but it is not built for analysis, or it's not very good at analytics workloads. So in order to be able to query this data, we need to transform it into column store format, which is suitable for analytical workloads. Analytical store is automatically created in Cosmos DB for you when you turn on this Azure Synapse link. So the existing data in Cosmos DB is converted into this optimized columnar store format and moved to analytical store. Sorry, not moved. Transformed, copied and transformed. And also, as soon as a new transaction arrives to transactional store, it will be also transformed into analytical store. And it is kept in auto sync, which provides you with the near real-time reporting capabilities on top of your Cosmos DB database. There are some other usages for analytical store. You can use it for keeping a history of your data, like archiving, or you can decide to use it for analytics on top of your operational data. Important thing to note here is that when you query analytical store, you are not charged for Cosmos DB usage, because this analytical store is completely separated. So you're in Cosmos DB, you're charged for operations over transactional store, as you are today, as you were yesterday. And for analytical store, you are charged only, when you query analytical store, you are charged by the way that your capability that you use to query it is charging you. So it's a Spark or a SQL Serverless in this case. So both Spark and SQL users can apply analytics on top of operational data from Cosmos DB in a near real time with just one click to configure it. So from what we saw today, there are many challenges in extracting insights from your data. We mentioned making a decision whether you need data lake or data warehouse, or maybe you need both. Then you have to see whether you have a needed skill set in your organization, or maybe you need to build some skill set. Then you have challenges to overcome of maintaining both systems to have best of the both worlds. And you have to put a lot of effort to make these things work, and you expose yourself at risk of not fulfilling the business SLAs. Azure Synapse Analytics resolve these challenges so you can focus on insights. The great thing is that you can start gradually. With Azure Synapse Serverless SQL Pool, you can start cheap and in small steps to query data in your data lake. There is no need to set up infrastructure, no worries about the resources, just connect to the endpoint and query your data. And as you progress and as your analytics solution advances, you can loop in on different teams to build on top of each other's work and let each team work in the capability, in the language, in the service they know best, whether it would be Spark or a SQL data warehouse or just SQL serverless. Turning data into insights might seem like a complex effort. I realize that, or something that is reserved for large teams within a big organizations. But with Synapse Analytics, you can confidently start building. And I would like to encourage you to go to Azure portal to create Azure Synapse Analytics workspace. Getting insights out of your data has never been easier, and it's just a few clicks away.
Hi, Filip.
Hi, Vladimir.
Great presentation. I think that is a really good addition to last year's keynote, but I also think that so many people don't know how that was last year and what was in preview last year and how that exactly works. As far as I see, we don't have any specific question right till now, but I have one question for you.
Sure.
Based on my experience and how that exactly looks like, because I see that clients trying to implement new things in Azure, especially from the data perspective, that is really important today for bigger companies. Do you have any kind of analytics? What is the usage of Synapse? Because it's pretty new, even though it's 1 year old. That is a pretty new service. Is there any big usage at the moment, or still in adopting or something like that?
Well, I don't have a particular analytics to share, but I can share what I see in the field. As you said, the service is somewhat a year, maybe a bit more there, in the public, and the usage is actually growing. But the usage actually started growing even more after we moved to GA, which of course makes sense because the companies want to take a dependency on something that is GA, not on a preview, at least in most cases. It's interesting that we see customers coming up with the new scenarios, some that we didn't even think of, like we have a customer that is building ETL pipelines for their customers, and now they started using serverless during a preview to quickly investigate what's in the files, but very soon their developers started actually building the complete extraction statements in a serverless, and then just discarding some components of their pipelines and feed those statement queries directly into the source queries of ADF, of Azure Data Factory. So many new things that we see. All kinds of customers are coming, and one of the impressions that we get, actually the feedback we get, is a great thing that they can start with their own technology, their own capability they use, like let's say SQL, and then they start building. And then when others in their company see that it works, and when they learn that they can also use a Spark, they can use Azure Data Pipelines, Azure Data Factory, then it all fits together for them, and then easily they loop in other users. So overall, the usage is growing, and we see it growing since the beginning, but of course it's increasing and increasing, and after GA it's increasing even more. Speaking of production users, yeah, sure, there are production users, and we are very happy with the results so far.
Okay, great elaboration. We have actually one question right now regarding Power BI. What is the recommendation to use Power BI direct query or caching data on the client side?
That's a very good question. I didn't have time to go through it in the presentation. When you use Power BI, you can decide whether you want to use import mode or direct query mode. Having in mind that the serverless is charged per query, you want to take a note of that, of course. So if you use import mode, you will be able to predict or estimate with a great precision your costs, because you will know if you refresh the data sets once a day, twice a day, and you know the amount of data that you processed, you can just calculate how much it will cost you. But if you have dashboard, which is near real time and hundreds of users refreshing it all the time, then your charges may add up. So you want to take that into consideration. Other than that, you can use both. We see customers using both. So yeah, that's the one thing that I would like to point out.
Great. Thank you very much. And then as far as I see from the field, people definitely having plans, developers and the data teams in bigger companies to leverage Azure Synapse, especially because I had one call yesterday with a potential client that will integrate that with the data factory to pulling data from subtables for some bigger analytics.
So I'm sorry, I had some interruptions in audio. I missed the question. I'm sorry. Can you repeat, Vladimir, please?
No, that was not the question. Just elaboration that from my side, that from as I see on the field, people definitely will leverage Azure Synapse in forthcoming period. We had one call with bigger client yesterday that definitely want to use a data factory with collaboration with Azure Synapse to pulling data from subtables for analytics. And we have one question. Can we compare cost of this with Azure Data Warehouse?
Well, that's a challenging question. Well, I would say you can, although it would need some homework from your side. For Data Warehouse, you can easily predict the price, the costs based on uptime and the size of data warehouse that you use. For serverless, you can connect, you can execute your queries or your workload and see the data processed which is there. And then you can see how often this workload will be executed, how many users will there be, and then you can make some estimation. What we see so far is that if you have high concurrency, high throughput requirements, milliseconds response times, then you will probably do better with SQL Data Warehouse or dedicated SQL Pool, as we call it in Azure Synapse Analytics. While serverless is better for some ad hoc intermittent workloads where you do not expect sub-second responses.
Okay, thank you very much for the good presentation. And I hope that next year we will see in person on bigger event than this year and previous. And we are going to prepare for the next session in a few minutes.
Thank you, Vladimir. Thank you, everyone. Bye.
Bye. Have a nice day.